Jai Hind everyone. I am Vivek Kumar Pansari, Assistant Professor in Department of Mechanical Engineering at Akgec Garg Engineering College. In the lecture series of important topics and questions related to Unit 1, I covered many topics and questions related to the Unit 1 which are asked in university exam. So, most of them are covered, and we were discussing in previous video about the numerical problems. So, some numerical problems we already concluded. Okay. So, this one we already done. Okay, to find out the support reaction. I hope you can refer my previous video related to that. Now, I am coming to the another video or another problem which was asked in the university exam. Okay, so some part I think it is not visible. It is 30 kilonewton per meter. It is 3 meters. It is 50 kilonewton. It is 1.5 meters and it is 1 meter. So, I think it is now visible to everyone, and each and every data is clear. Which type of load this is? This is the uniformly distributed load. We know this. Okay. Which type of support here? At A, it is a hinge support, and when we replace hinge support, it will be replaced by two reaction forces. One is horizontal reaction, that is RAX, and the second one in the y direction, that is RAY. At point D, you are observing that there is a roller. So, at point D, there will be a reaction force which is vertically upward, RD. And for finding out the unknown reaction forces RAX, RAY and RD, now we have to apply equilibrium equations. So, equilibrium equations, as we are observing, it is a two-dimensional force system. So, for that the equilibrium equations are sigma Fx equals to 0. Sigma Fx equal to 0. How many forces are there in horizontal direction? We are observing that there is only one force, RAX. So, that RAX, any other external force? No. So, it will be 0. So, RAX equal to 0. Second, we can write equation, that is sigma Fy equals to 0. Now, write the equation. RAY vertically upward plus RD. Okay, these are the two vertically upward forces in this diagram. And what are the downward forces? As this is the UDL, it is spreaded over the 3 meters of length. If I am converting it into a single load, then it will be at the midpoint, and this load will be 30 into 3, and the direction of this will be downward. So, that is 30 into 3. Okay. Now, moving ahead, we are again observing there is one more downward force which is 50 kilonewton. So, that is 50 kilonewton. 50 kilonewton, that is equals to 0, 50 kilonewton. Any other force? No other. So, RAY plus RD minus 30 into 3, that is the UDL, and this is the 50 kilonewton which is the point load at point C. There are two unknowns. For finding out two unknowns, we need one more equation. So, let us write a equation of moment about any point. I am choosing point A. So, sigma MA equals to 0. Algebraic sum of all the moments about point A equals to 0. So, let us begin from the point A. There are two forces, RAX and RAY. Both these forces are passing through point A. So, the perpendicular distance of RAX from A is 0, RAY from A is 0. So, the moment due to RAX and RAY about point A is 0. Now, I am coming to the second force, which is a point load representing the UDL, which is spreaded over the 3 meters of length. And how much will be the distance? Distance will be the 3 by 2, half of the length over which the UDL is spreaded. जितनी लेंथ पर UDL स्प्रेडेड है उसके मिड पॉइंट पर मैं उसे एक पॉइंट लोड से रिप्रेजेंट कर सकता हूं. Okay, so what will be it is? So 30 into 3, 30 into 3, that is the load. Moment perpendicular distance और लेना होगी, force into perpendicular distance. How much is the distance? The distance is 3 by 2. Which type of tendency of rotation it is having? So the clockwise tendency of rotation about point A. Clear? So I am taking it as a positive. Now I am coming to the 50 kilonewton. The moment due to 50 kilonewton about point A. So what is the distance of 50 kilonewton from point A? 3 plus 1.5, 4.5. So 50, this is the force, and the distance is 3 plus 1.5. Okay. Now RD, what is the distance of RD? So 3 plus 1.5 plus 1, so 5.5. And the tendency of rotation because of RD will be anti-clockwise. So minus RD into 5.5 equals to 0. Please check these equations. I hope both the equations are okay to you. There is no issue at all. Okay. And find out RAY and RD. Okay. RD, you can calculate. RD is coming out 65.45 kilonewton. Calculate करना है, copy नहीं करना है. Okay. RD 65.45 and RA by equals to how much? Calculating 74.54 kilonewton. Check करिएगा. Very common question in each and every exam of first year. It is asked to find out support reaction. Very simple. If it is for 7 marks, then very good for any student. Okay. So this back. Now we are moving towards some more questions related to support reaction. Earlier we deal with simply supported beam. This is the simply supported beam. This is the simply supported beam. Now the beam type is, which type of beam it is? It is the cantilever type of beam. Which type of beam it is? Cantilever beam. Cantilever beam means one end is fixed and the other end is free. So for these kind of question, how to move? So first, this is what the, which type of support? Fixed support. कैसा support है? Fixed support. How many motions are restricted? May this beam move in the horizontal plane? No. So one restriction. क्या ये इस डायरेक्शन में बाई डायरेक्शन में मूव कर सकती है? Second restriction. Is it possible for this beam to rotate about point A? No. So there are three restrictions. So whenever we are dealing with the fixed support or cantilever beam, there are three reactions: RA by RA X, and the tendency of rotation clockwise because of all the loads. So for supporting that, there will be reactive movement at point A, that is the MA. Okay. So these are the three unknowns we are having. Now again, this is a two-dimensional force system. For a two-dimensional force system, we are having three conditions of equilibrium: sigma Fx equal to 0, sigma Fy equal to 0, and sigma M equals to 0. So sigma Fx, Rax. Is there any other force in horizontal direction? No. So Rax equals to 0. Any other? Second equation will be sigma Fy equals to 0. So let's write the sigma, matlab algebraic sum of all the forces in bidirection. So let's start from here. Ray, then UDL. Now we know how to write UDL. 20 into 2. 20 kilonewton per meter is the intensity over the 2 meters of length. It is spreaded. So 20 into 2. That is the point load through which we can represent this UDL. Then minus 15. Then this is the couple. So no need to write in the force equation. Then coming to at point B, so there is the 10 equals to 0. Check out this equation. I hope the equation is quite clear. No issue at all. 20 into 2, 15 and 10. Now, for finding out RAY, we can get from here, but one more variable is there, that is the MA. Let's write the equation sigma MA equals to 0. Algebraic sum of all the moments about point A equals to 0. So let's begin from here. 20 into 2. What will be the distance of 20 into 2 from point A? It will be definitely at the midpoint. So this distance will be how much? This distance will be 1 meter. So 20 into 2 into 2 by 2. And tendency of rotation will be clockwise. Now I am coming to the 15 kilonewton. 15 kilonewton. What is the distance of this 15 kilonewton from point A? 15. That is the load. Distance is 3 meters. Now I am coming to this couple. 15 kilonewton से कैसा था tendency of rotation? Clockwise. This couple is also clockwise. So definitely this will be added to the equation. 30 kilonewton meter plus tendency of rotation by 15 kilonewton, tendency of rotation because of the UDL, all are clockwise. So that will be summed up. 10 kilonewton, what is the distance of this? 2, 3, 4, 5. So force into perpendicular distance. Force into perpendicular distance. All these are clockwise. Which is reacting over it? The MA, the reactive moment at point A. So that is minus MA equals to 0. Check out the equation. I hope the equation is quite clear to you. 20 into 2 into 2 by 2 plus 15 into 3 plus 30, that is the couple, and 10 into 5 minus MA equals to 0. By solving both these equations, you will be able to get RA by, from the second equation, it is clearly visible, that is equal to 65 kilonewton, and MA, how much it will be? MA calculate कर सकते हैं from the third equation. How much it is? It is, calculate कर लें, it is 165 kilonewton meter. Will there be any moment due to RAX and RA by about point A? इसकी वजह से या इसकी वजह से ये point के about कोई moment होगा क्या? No. The moment क्यों नहीं होगा? Because both these forces are passing through point A. So I hope the question is quite clear. The next question you can try at your own. So that will be done by you only. If there is any issue, then problem, then you can write to me. So these numerical problems that earlier in the previous video I solved for you, this is discussed right now, and this is. So you will be finding definitely a question related to the support reaction calculation for different type of beams and different loading conditions. So I hope now you are comfortable with the questions related to support reactions. Thank you very much for watching the video.